Hello, everybody, and welcome to your 9-2 notes. So, continuing on with transformations, today you're going to learn about translations. So, translations is just when you take a figure and slide it somewhere else. Okay, it slides all points of the figure the same distance and direction. So, for example, they took triangle ABC and translated it along this vector. That's what that arrow is called. To A prime, B prime, C prime. Okay, they are rigid motions because they do not change the size or shape of the figure. It just slides it around on the coordinate plane. So, for example 1, we want to tell whether each transformation appears to be a translation. So, looking at A, it is not a translation because this flips over here. So, this is actually a reflection with your line of reflection there. So, we can say no. It's a reflection. All right. Looking here, trying to figure out if this is a translation, and it is, because this blue figure slides left and up to the red one. So we can say that, yes, this is a translation. So go ahead and do the next two on your own. Pause the video and then unpause when you're ready. All right, so looking at this one, we can say that, yes, it is a translation because it goes from the blue figure, slides down and to the left. So we can say that, yes, this is a translation. And then looking at this one actually rotates, okay? It rotates from here all the way up to there. So we can say, no, it's a rotation. All right, so that kind of showed you the difference between a translation and a rotation and a reflection. So now what we're going to talk about is naming our vectors. So your vector is the quantity that holds both direction and magnitude. Okay, so your vector is what a point moves along. Okay, your initial point is your starting point. Okay, your terminal point is your ending point. So in this figure, our initial point is E. We translate across this vector and get to F, okay? When you name vectors, you start with your initial point, go to where your arrow is, okay? Let me erase this. So notice this is your arrow, okay? So you go to where your arrow is, and then you draw on top like a ray, but you only use one arrow, okay? So you always start with your initial point, and with your terminal point, or where the arrow is, and then you draw it like an arrow, but not this bottom piece. Oh. But not this bottom piece. That goes away. Okay? So when you're naming a vector, you can use what's called component form. Okay? So component form is going to be what I call pointy parentheses, your x value or your x change. So this is your x change, comma, your y change. And like I said, it specifies how far you're going left or right, how far you're going up and down. Okay? If it's negative on the x value, you'd be going left. And then if it's positive, you'd be going right. So that's left and right. This one signifies up and down. Okay? So component form from P to Q. And again, you would name this vector P, Q, with your arrow thingy above Q, is 5, 3, because you do your horizontal change first, so it went to the right 5, and then it went up 3, okay? So that's component form would be pointy parentheses, positive 5, positive 3, because both those directions are positive. The other kind that you guys are familiar with is coordinate notation. So we did a little bit of this in the last notes where it's literally going to tell you add 5 to your x or add 3 to your x. Okay? These tell you the exact same thing and they can be interchangeable. So this is component form. This is coordinate notation. You will need to know the difference between the two, so make note of that. So we're going to look at our vector to the left here, and the first thing we want to do is to name the vector, identify the initial point and the terminal point. So my initial point is the point that does not have the arrow. So my initial point is this point M. okay? The terminal point is the point that does have the arrow, so that would be here at N. So when I name the vector, you start with your initial point, then you go to where your arrow is and draw that half arrow above it. So that vector is called MN. Now we want to write it in write the vector in component form, okay? So to write the vector in component form, we identify the horizontal change and the vertical change from the initial point, so we start at M, and to the terminal point. So my horizontal change, we just count 1, 2, 3, 4. Okay, so we went to the right 4, which is positive, so it's a positive 4. The vertical change is down 2, so that's a negative 2. So then when we put those into vector, or when we name the vector, we put it into pointy parentheses. So that would be 4, comma, negative 2. All right, 1A says, is vector xy the same as vector yx? Why or why not? Well, the reason is that this vector has an initial point of x and a terminal point of y, and this one has an initial point of y and a terminal point of x. So no, they have different initial and terminal points. Okay, because just like when you name an array, when you name a vector, you have to start with your endpoint, okay? So now what we want to do is we want to go ahead and figure out how to translate on a grid. So over here, A says, before we draw the image, we want to predict the quadrant in which the triangle will lie. So make note of this. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. You will need to know where your quadrants are for your test, so make note of that. Okay, so we're going -3 left to right and up 2. Okay, positive 2, which is up. So we're going to take this whole figure, go left 3 and up 2. So the quadrant we're going to end up in is quadrant 2. Okay, I don't know exactly where in quadrant 2, but I know that's where I'm going to end up. Now what we're going to do is in the table, I'm going to go ahead and translate it. So again, when you do a translation, all you're going to do is take your x value, plug it in for x, take your y value, plug it in for y, and solve. So first, we have 0 for our x. So 0 minus 3 gives me a negative 3. And then you have 3 for your y, so 3 plus 2 gives me 5. So that's 1 point. Now we're going to do it the next one. 1 minus 3 gives me a negative 2. Negative 1 plus 2 gives me a positive 1, excuse me. Finally, we have negative 1 minus 3 gives me a negative 4. Negative 1 plus 2 gives me a 1. So now I'm going to go ahead and plot all those points. So I'm going to go left, 1, 2, 3, up, 1, 2, 3, 4, 5. So there's 1 point. Then I'm going to go left, 1, 2, up, 1, and negative 4, positive 1. So when you connect your dots, this is going to be your new triangle. Now, another way you can do this is you can literally take each point. This signifies left 2, or left 3, excuse me, and that signifies up 2. Because remember, your x is left and right, your y is up and down. So I could take this point and count left, 1, 2, 3, and then count up, 1, 2, plot that point. Count left, 1, 2, 3, up, 1, 2. Left, 1, 2, 3, up, 1, 2. Okay, that's the exact same thing. All right, so either create a table and figure it out, or just count on your figure. Now what we're going to do is we're going to take an already translated figure and write it in coordinate notation, which is that x, comma, y, and then goes to x something, comma, y something, and it tells me what it is. Component form is your pointy parentheses. Okay, so what I need to do is I need to figure out how far this triangle goes to get to this triangle. So I'm going to count each point. L, okay, so we're going by 2, so this is 4, this is 2. So this is kind of off, but this is actually at 5. So to get to here, we are going to go vertical change first. So I go to the right 1, 2, 3, 4, 5, 6. Okay, so because I'm going to the right 6, that's positive. So this is going to be, let me move this. I'm going to put this down here. So we're going right 6. So right is positive, so that's going to be x comma y is translated x plus 6 comma. And then in my pointy parentheses, we put a positive 6. And then we're going, so we went right 6, and then we go up 1, 2, 3. And again, we're going up 3. So that's a positive 3. So this would be y plus 3. And this would be a positive 3, and close your pointy parentheses. All right. So right and up is positive. Left and down are both negative. All right. And again, the reason I knew to start with the yellow one and go to the green was because of these primes. Okay. Those primes tell me that that is our image, and our non-prime tells me that's our pre-image. So go ahead and get started on the homework unless you have questions. If you have questions, let me know.